Now, let us begin our actual chapter, Parabola. So, Parabola, the locus of a point which moves in a plane such that its distance from a focus means fixed point, from a focus is always equal to its distance from a fixed point. It's called parabola. So what it says? Let S be the focus. Let S be the focus. L be the directrix. L be the directrix. Let P be any point in the plane such that any point in the plane, and M be the projection of so here P be any point in the plane, M be the projection of P on L equals to 0. M is this. Let M be the projection of P on L equals to 0. Then the locus of P such that SP by PM is equals to E, where E is equals to 1, then SP is equals to PM. That means let P be any point in the plane, its distance from a fixed point, that is focus, to its distance from a fixed line. These two must be equal. Likewise, if you take another point, its distance, for example, this is P2 now. Its distance from a fixed point. Next step, its distance from a fixed line are equal. Another point, if you take its distance from a fixed point to its distance from a fixed line. Likewise, if you take this point, for example, its distance, this is P3, now P4, its distance from a fixed point by its distance from a fixed line. So, this is equals to this, and the locus of all such points, if you join, then the shape obtained is called a parabola. So SP by PM equals to 1, then SP is equals to PM. Let Z be the projection. Let Z be the projection of S on L equals to 0, that is this Z. Z be the projection of S on L equals to 0, then SZ is called the principal axis. SZ is called the principal axis. So, we will now derive the equation of a parabola in its standard or simplest form. A parabola is said to be in its standard or simplest form if and only if its vertex is at the origin and it is either symmetric about x-axis or y-axis. Now we shall derive the equation of a parabola in its standard form. Equation of a parabola in its standard form. That is y square equals to 4ax. So let F be the focus and L equals to 0 be the directrix and P be any point in the plane. Next step. Let M comma Z be the projections or feet of the perpendiculars of P comma S on the directrix L equals to 0 respectively. Let N be the projection of P on SZ. On SZ, what is SZ? Principal axis of P on SZ, principal axis. Let AS be treated as positive x-axis and AY be treated as positive y-axis. AY be treated as positive y-axis. Let A be the midpoint of SZ such that SA is equals to AZ is equals to SA is equals to AZ. Then by the definition of a conic, A lies on the parabola. A lies on the parabola. Let SCI is equals to AZ is equals to A. So let us try to draw the diagram of what we have written so far. See this. This is the chorded axis. Let this be the parabola located on the right hand side of the y-axis. It may be left hand side of the y-axis as well. Otherwise, it would be upward parabola, downward. All these parabolas are said to be the parabolas in their standard form. So, but for convenience, let us take any one of them. So, let S be the focus. What is focus? It's a fixed point. And L is equals to 0 with the directrix. S be the focus. L equals to 0 with the directrix. And P be any point in the plane. So in this plane, I'll take a P be any point. For example, this P be any point in the plane. M comma Z be the projection or feet of the perpendiculars. So M comma Z be the projections of what? M is the projection of P and Z be the projection of S on the directrix L equals to 0. Therefore, this is L equals to 0 directrix. This N is the projection of P on L equals to 0. Similarly, this Z is the projection of S on L equals to 0. Or we can say the feet of the perpendiculars also. Next, let N be the projection of P on SZ. So, I'll take this point N. This N is the projection of P. So, this point N be the projection of P on the SZ is what? It's a principal axis. Okay. Principal axis. Let AS be treated as positive x-axis. So, this is A. So, A is called vertex. So, what is vertex? The point of intersection of a conic and the principal axis. What is principal axis? Principal axis is that straight line which is passing through the fixed point. I'm talking about this. So, AS is called the principal axis. Why? Because this is a straight line passing through the fixed point focus and this straight line is perpendicular to the fixed line directrix. Okay. AS be treated as positive x-axis. And what is A? A is called the vertex. Why? Because the vertex is defined to be the point of intersection of a conic. What is the conic here? Parabola. The point of intersection of this parabola and this x-axis, which is principal axis, are intersecting at this point A. So, this be treated as positive x-axis and AY. This is y-axis. This is x-axis. This is y-axis. Negative x-axis, y dash. AS be treated as positive x-axis and AY be treated as the negative y-axis. AY be treated as positive y-axis. Let A be the midpoint of SZ. That means this and this are equal. A be the midpoint of SZ such that if it is a midpoint, AZ is equals to AS, then by the definition of a conic, what is the conic definition? Its distance from a fixed point is equals to its distance from a fixed line. So that is why if it is so, then A lies in the parabola. Let SA is equals to AZ is equals to A. So this is the origin 0, 0. This is A comma 0 and this is minus A comma 0. Let AS is equals to A. Then S is A comma 0, Z is A minus A comma 0. And the equation of the directrix L is, so equation of the directrix is this, and this is the line which is parallel to y-axis. Any line which is parallel to y-axis is of the form x equals to k. So L is x equals to k. K in the sense this is A and this is also A. So x is equals to minus A. This is x equals to, this is A. But speaking from the coordinates perspective, this is x equals to minus A is this line. So x equals to A, that is x plus A is equals to 0. Let P x1 y1, let P x1 y1 be the locus of the parabola. Since P lies on since P lies on the parabola, so its distance from a focus SP by definition of a conic, its distance from a fixed point by its distance from a fixed line is equals to E, eccentricity E. That E is equals to 1 in the case of parabola. That is SP is equals to PM. What is SP? SP is the distance between these 2 points, A comma 0 and x1 y1. That is square root of x1 minus a whole square plus y1 minus 0 whole square. And what is PM? PM is nothing but perpendicular distance from P x1 y1 to the line. What is this line? X plus a is equals to 0. PM is the perpendicular distance from P x1 comma y1 to the line x plus a equals to 0. That is equals to perpendicular distance x1 plus a by square root of 1 square root of ax plus by plus c equals to 0 and x1 y1. Ax1 plus by1 plus c by square root of quotient of x square of the quotient of x plus square of the quotient of y. That is root 1. This is simply x1 plus a. And PM is equals to how much? PM is equals to this nz. Why? Because this is the perpendicular and this is also 90 degrees. That means, and this is also 90 degrees. N is the projection, M is the projection, and Z is the projection. N is the projection of P, M is the projection of P on L equals to 0. Z is the projection of S on L equals to 0, and N is the projection of P on SZ principal axis. Therefore, this is 90, this is 90, this is 90. So this also should be 90 degrees. Therefore, PMZN is a rectangle. Then PM is equals to, according to the property of rectangle, opposite sides are equal. So PM is equals to NZ. And what is this NZ? NZ is nothing but NA plus AZ. NA plus AZ. What is NA? NA. So since this is the origin, NA is nothing but x1 and Pn is nothing but y1. Since it is acting as an origin. So N is at a distance of x1 units from the y-axis and Pn is the y1, this y component. So Na plus Az, Na is x1 plus Az. What is Az? This is A and this is also SA is equals to AZ is equals to. SA is equals to AZ is equals to A we have taken earlier. This is also A and this is also A. That means x1 plus A. Now from this SP is equals to PM. If you square on both sides, SP square equals to PM square. Then what is SP square here? What is SP square? SP square is this. SP is this. SP square is square and root will get eliminated. Therefore, we are left with x1 minus a whole square plus y1 square is equals to PM is equals to, in both the ways I have proved, PM is x1 plus a. The same PM is, if you proceed through the rectangle, also x1 plus a. So here only one is enough, but for your convenience, actually, if you could not understand this, so you can understand with this. Okay, so PM is nothing but x1 plus a square. Now x1 square plus a square minus 2a x1 plus y1 square is equals to x1 square plus a square plus 2a x1. x1 square a square, x1 square a square gets cancelled. Therefore, y1 square is equals to this minus 2a x1. If you transpose on that side, 2a x1 plus 2a x1, 4a x1. Therefore, the locus of P x1 y1 is, if you remove this x1 y1, then actually the general equation, actually the behavior of this point in the plane we get. So behavior of such points, if you generalize, then actually the whole equation of the parabola we will be getting. Therefore, the locus of P x1 y1 is y square equals to 4ax, which is the standard form of the parabola whose vertex is at the origin and which is symmetric about the positive x-axis, which we will be learning afterwards. Let us discuss some definitions of a parabola. Some definitions. First of all, chord. The line joining. So in conic sections also we have discussed all of them. But once again, let us see this. The line joining any 2 points of a parabola is called a chord. That means this is the parabola. So these two are the points of this is the line joining of the 2 points of a parabola. So this line is called the chord, focal chord. The chord passing through the focus. Focus means parabola is called focal chord. So let this be the parabola and this be the focus. So this time, earlier focus is somewhere here. This chord is not passing through the focus earlier. That is a chord. Now the chord passing through the focus. So this is the focal chord. Like these chords, many chords, infinite number of chords can be drawn. So this likewise here also passing through the focus, there may be number of infinite focal chords can be possible. So if you draw like this and all. And double ordinate. The chord which is perpendicular to the chord which is perpendicular to the principal axis is called double ordinate. So before that, what is vertex? The point of intersection of a conic and and axis. So principal axis can be shortly termed as axis also, is called vertex. That means this is the parabola, this is the parabola, and this is the axis. So both are intersecting at this point. This point is called the vertex A. Now, what is the principal axis? The principal axis is a straight line passing through the focus and perpendicular to the fixed line. So, okay. Principal axis is what? So actually we should have written it earlier, but no problem. The principal axis, the straight line which is passing through the fixed point focus and perpendicular to the fixed line directrix is called principal axis or principal axis. That means if you have a parabola like this, now this is the fixed point and this is the fixed line, L equals to 0. The point of so the straight line which is passing through the focus and perpendicular to the directrix, this straight line is called the principal axis. Now, what is double ordinate? The chord which is perpendicular to the principal axis. So, for example, this is my parabola and this is focus S and this is my principal axis. Okay, this is my principal axis. The chord which is perpendicular to the principal axis. Here it is not passing to the focus like the focal chord, and the focal chord is not perpendicular to the axis. This focal chord is not perpendicular to the principal axis, not straight, but here it is straight, it is double ordinate. Now, latus rectum. The focal chord means passing to the focus. The focal chord which is perpendicular to the axis or the double ordinate means which is perpendicular. The double ordinate passing through the focus. Is called latus rectum. That means if you take the diagram like this, this is our focus. This is our focus, and this line is called the chord. Because why chord? This is the line joining of any two points of this parabola. This is the chord. This chord is passing to the focus, therefore it is focal chord, and this focal chord is perpendicular to the principal axis. Otherwise, this is a double ordinate because this chord is perpendicular to the principal axis and passing to the focus. So, from focal chord as well as double ordinate perspective, we can define the latus rectum. Focal distance, the distance of a point P on the parabola. Let us take, this is the point P on the parabola. The distance of a point P on the parabola from its focus. Let P be x1, y1 and s be a comma 0. The distance of a P on the parabola from its fixed point focus is called the focal distance SP. So here SP is equals to how much? Distance between the 2 points. Square root of x1 minus a whole square plus y1 minus 0 whole square. This is equals to x1 square plus a square minus 2ax1 plus y1 square. So this is equals to x1 square plus a square minus 2ax1. Since p x1 y1 lies on the parabola, so this must satisfy the equation of the parabola. So parabola b square equals to 4ax. It must satisfy. That means y1 square equals to 4ax1. So this y1 square can be replaced as 4ax1 now. Now this is x1 square plus a square plus 4ax1 minus 2ax1 is plus 2ax1. So this can be x1 plus a whole square. This is x1 plus a modulus. Therefore, this is this x1 plus a. The length of the focal distance of P from the fixed point is called the focal distance. The length of the lattice rectum of the parabola y square equals to 4x is 4a. So, this is our parabola and this is focus. This is directrix L equals to 0, fixed line, fixed point focus, and this L dash, L comma L dash is what? It is a chord. This chord is passing through the focal chord, and this focal chord is perpendicular to the principal axis, double ordinate. Okay, na? So this focal chord is perpendicular to the axis. Therefore, it is a lattice rectum. So let L comma L dash be the ends of the lattice rectum. So this is A and this is Z. Z is the projection of S on L equals to 0. So ZA equals to AS. A is the midpoint of ZS. This is A comma 0. That means this is minus A comma 0. A is the midpoint. Therefore, this is A as well as this is also A. So, if it is A comma 0, then this would be A comma, this would be A comma. This height I don't know. For which let us take L. So, here this is minus L. Therefore, L dash is equals to how much? 2L. This is L and this is L. So L dash is equals to 2L. What is L dash? The length of the lattice rectum. Okay. Now, so since L comma L dash are the points on the parabola, so that implies A comma plus or minus L must satisfy the equation of the parabola y square equals to 4ax. A comma L and A comma minus L. These 2 points are lying on the parabola. Therefore, the points must satisfy the equation of the line, equation of the parabola. So that implies y square here is L square equals to 4a. What is x here? A. So this is 4a square. L square equals to. Therefore, L is equals to plus or minus 2a. Therefore, L is equals to, here L is equals to a comma plus 2a and L dash is equals to a comma minus 2a. or the end points, or in other words, extremities of the latus rectum, and the length of the latus rectum is length of the latus rectum is equals to LL dash. LL dash is SL plus SL dash. SL plus SL dash. That is L plus L. 2L. So 2 into what is L? 2A. So 4A. So length of the latus rectum, this is totally 4A.